Okay, so we still look at the two algebra. So this will be the two algebra that are direct proportion. So do you still form the same formula? Yes, you still form the same formula. So you can put the formula side by side first. So based on the formula, right, we are going to look at different contexts. So all the four questions have different scenario. So for example, what is the first scenario? Let's take a look. So the first scenario talk about a square. So try to draw it out if you can. So this is a square, try to draw it out. Then the square, right, are all x. And y represent the area. So y represent the area of a square. So if you break down this, you will realize that, oh, that means it's y equal to x squared. Can see? Length and breadth will give you area, right? So your job is to compare with the formula. Compare with the direct proportion formula. When you do a comparison, you will get the answer. You will get the answer for n. So in fact, right, you also get the answer for k. Do you realize you also get the answer for k? You also get the answer for n, but they never ask for k. So anyway, they never ask for k, so I won't answer them. So if I compare, right, my n is 2. And if they need, right, k is actually equal to 1. So this one, right, is I'm comparing the situation with the direct proportion formula. Okay, so this is how they can ask. So we compare the formula for direct proportion against an area formula. Okay, so we're going to compare the direct proportion formula. And upon the comparison, you can see what's the value of n. So in the next context, right, it is still a direct proportion. But then it is a circle. So this is a circle, radius x. And y is the area. So I'm guessing some of you may forgotten. Do you remember area of a circle? Do you remember it's pi r squared? And the radius is x. Matthias, 2 pi r? 2 pi r squared is not. I think you mix up with the circumference formula. Circumference is 2 pi r. Area of the circle is pi r squared. So again, right, you put the direct proportion side by side. Okay, let's try to put it side by side. We put it side by side. Can you see that your n is equal to 2? And your k is equal to pi. Anyway, k is a number. So every context, I'm going to compare it with the direct proportion formula. They can come up with a lot of contexts. And then your job is to compare with the formula. Can I give you like 1 minute? You can think about part C. If you want, you draw it up. So every question I'm going to compare with my direct proportion. So every question I'm going to compare. So the next one, we talk about a cube. I think some of you may be like, what is a cube? Okay, if you know what is a 6-sided dice, that is a cube, like this. It's like the ice cube. So all the sides are X. You can see all the sides are X. And Y is the volume. Do you remember the volume? I think some of you may be like, wow, totally forgot. I think the second half of this year, you still have the volume and surface area topic, which Kyla and Abigail have completed last year. But I think you all still need a bit of practice is for the cone, pyramid, all that. And it makes in with Pythagoras theorem. Okay, so if you still remember the volume of a cube is length times breadth times height. Remember, in primary school, we learned that it is length times breadth times height. So it will be x times x times x. It will be x cubed. Okay, put it with the direct proportion and you do a comparison. Can you see that n is equal to 3? You put it with the direct proportion and you can also see what is your k. Your k is equal to 1. Okay, the reason why I put in bracket because the question never asks for k. The question only asks for n. So I cannot tell you what will come up. They can have different formulas, but you just have to compare with the direct proportion formula. So far we have been comparing area and volume. The last one, you're supposed to compare with the speed, distance, and time. I'm going to help you out with the triangle first. Here, I'm going to give you 1 minute to try. So this kind, right, don't need calculation. It's like comparing. It's actually harder because the idea of comparing is a different technique. Abigail, a little bit wrong, but good try, Abigail. Yeah, Abigail, good try. Okay, a little bit wrong. Okay, the constant speed, right? If you don't know what is the speed, you put it as a k. If you don't know what is the speed, you just put it as a constant, like it is a number that doesn't change. Maybe it's 60 km/h. I also don't know. Okay, so what you can do is you assign the constant speed as a number first. Then you can change a triangle. Some people go and change a triangle. I learned it from one of the other students. So what the student did was, right, the speed, right, she put it as a K. The distance, she put it as a X. Then the time, she put it as a Y here. So from here, right, Y is equal to X over K. So Abigail, you cannot put it as a 1. Okay, otherwise you are actually correct. So it is a 1 over Kx. So if we do the comparison, okay, if we do the comparison, Abigail, your N is actually correct. So your N is 1. The constant is like 1 over K. The constant is just a number. Doesn't matter. Okay, so Abigail, you are almost correct. It's just that you cannot put the K as 1. It has to be some unknown. It can be any unknown. It can be like A also can. Some people, they choose to put a A. As long as it's a number. So if you want things to be easier, then maybe we change it to alphabet A, so you don't see the confusion. So the constant is A. So K is essentially 1 over the speed. Whichever speed that the thing is traveling at. Okay, so you all have to look at the idea. There's a flexibility in a lot of situations, so I cannot tell you. You just have to compare on the spot. But what are we comparing with? We are comparing with the direct proportion. If you're done with this page, let me know.